Hi Bobcats, here's some advice for getting ready for the ACS final exam for Chem 1342. Here are some of the details about taking the exam. All of the procedures we've followed on our midterm exams will apply here, like removing hats with a brim or turning them around, no watches, no cell phones, no calculator covers, all of those sorts of things. I've always had it on the paperwork that I would check IDs, but I didn't usually have proctors, so that wasn't practical to do. But with the ACS final exam, I will be checking IDs when you turn in the exam. We ask with the ACS exam that you don't write on the test. You'll be given plenty of scratch paper, and I'll have extra as well. So if you go through the scratch paper that comes with your exam, I'll give you more. I'm happy to do that. All scratch paper must be turned in when you turn in the exam. The exam has 70 questions. Each question is weighted the exact same as all of the others. So I strongly recommend that if you feel like you're spending a lot of time on a question, that you make your best guess and move on, and maybe on your scratch paper keep a list of questions you wanted to come back to. The ACS rules are that you get 110 minutes for the exam. Our Gen Chem faculty decided last Friday that we're going to allow 130 minutes. This is an experiment in chemical education. We're going to see if adding 20 minutes to the exam time has an impact on outcomes. So we'll see. Fingers crossed that takes a little bit of the time pressure off. You can expect the same equations and constants that you were provided on the midterm. Those same equations and constants will be provided on the final exam. So take a look at the cover sheets to all of the midterm exams, and that's a pretty good indication of what you should expect on the final. And one last comment about the structure of the final. Some questions are things that we just didn't cover. The Texas State University's chemistry department did not write this exam. The American Chemical Society did. And so they are basing the exam on a wide variety of expectations. That's one of the reasons that there's a curve on the final exam. So if you're looking at a question and you're thinking, wow, this has a lot of chemistry words in it, but I have no idea what they're talking about, it may be a question we didn't cover. So make your best guess and move on. Don't waste time on questions like that. The questions on the exam are both conceptual questions and calculation questions. So I want to be real clear, I'm not saying you don't have to do any calculations. The calculations are still there, but there also are conceptual questions too. And a lot of the questions that involve calculations can be simplified by thinking about the relative concepts. At a minimum, you'll be able to eliminate some answers. And so even if you aren't sure how to proceed with a question, you can improve your chances of guessing by realizing that only one or two of the answers might be reasonable. Here's an example of what I mean by that. Let's say you don't remember anything about how to take corner atoms, edge atoms, and face atoms and turn that into an empirical formula. Well, even if you don't remember that, you can eliminate two of these answer choices because they are not empirical formulas. Empirical formulas mean that you have the smallest whole number ratio between the atoms. So in answer B, all three of those subscripts can be divided by 2. They could be reduced by dividing by 2. So that's not an empirical formula. And ditto for answer C. All of those subscripts can be divided by 3, so that is not an empirical formula. So if you had no idea what else to do, you know it would have to be either A or D, so you just took your answer choices from 4 to 2, so you just doubled your chances of guessing if you were to guess on this problem. For those of y'all who are wondering, that one, answer A is the correct answer. Okay, how about this question? What is the resulting pH when 0.015 moles of KOH are added to 1 liter of a buffer that is 0.555 molar in nitrous acid and 0.444 molar in potassium nitrite, and we're given Ka of nitrous acid? Just realized I'm not sure I brought a calculator out. Good, I've got one handy. Okay. So let's say you don't remember what it is you're supposed to do when you add acid or base to a buffer, but you do know that you use the Henderson-Hasselbalch equation to find the pH of a buffer. And so that equation says that pH is equal to pKa plus the log of the base form in the buffer divided by the acid form. All right, so nitrous acid is the acid form and potassium nitrite is the salt that provides its conjugate base. So we could find this by taking minus the log of Ka for nitrous acid, which is 5.6 times 10 to the negative 4, plus the log of the base form over the acid form, so that would be 0.444 divided by 0.555. Okay, so this calculation will get us the pH of the buffer before any strong base is added to it. So let me here just real quick run that through, run that through my calculator. I'm using currently a TI-30XA, so I'm kind of working this one backwards. I'm taking the ratio in that second log, 0.444, divided by 0.555, and then equals, and now I'm hitting the log key on that. And now I'm going to subtract from that the log of Ka, so minus 5.6 EE negative 4 log. And I get as an answer for this, okay, stop. Sorry, I had an alarm going off. I get as an answer for this 3.15. I'll take one more sig, 3.155. Okay, so this is the buffer before any base is added. So when we add KOH, we know that the pH has to go up. So the correct answer has to have a pH that's bigger than 3.155. And so it can't be 3.128. It can't be 1.754. So it's got to be one of these other two. If my memory serves me correctly, it's answer D, but short of setting up the ICF table and finding that, I wouldn't swear by that, but I think it's going to be answer D, because when you add strong acid or strong base to a buffer, the pH doesn't change much. So changing from 3.15 to 3.18, that's probably the most reasonable answer, but we can definitely eliminate A and B. So even if you weren't sure how to do all of the calculation, if you just understand that adding strong base to a buffer causes the pH to rise, you greatly improve your chances on this question. Okay, what would I recommend you do in order to prepare for this final exam? The first thing that I would recommend you do is you pull up our midterm exams. That's why I handed back the booklets to you. And you look at all of the questions on those exams and you ask yourself, what is the big picture on each one of these questions? Not just, the correct answer for this one is 7.2. That you're not going to see that same question on the ACS final. But if you have the knowledge and skills to successfully answer every question on our midterms, you have the knowledge and skills to successfully answer almost every question on the final exam. Again, there are a couple of questions on there that we didn't cover. Those are going to be curved for. But for all of the ones that we did cover, you're in great shape based on what's on the midterms. So I think my next slide has an example of a midterm exam question, and I'll talk to you about what I mean by looking for the big picture. The other thing that I would strongly recommend is that you go back to the lecture examples. For each one of those chapters, use what you have left on your Send and Print account, which is probably thousands of pages, and print a fresh copy of each of those lecture examples and act like each one of those is a test. And can you work through those lecture examples start to finish with just your brain and a calculator and like the cover sheets from the midterm exams, so that any equations that might be given are there. So I think these two things are the biggest things that you can do to help you get ready for the final exam. All right, here is a question from our last midterm exam. You're given the reaction for a galvanic cell, and you're asked which of these reactions would reduce the cell potential. Well, this is a Le Chatelier's principle type argument. If something is going to reduce or make the cell potential more negative, we want the something that's going to shift the equilibrium in the reverse direction. So if we're going to expand this and look at the big picture, well, it's asking about galvanic cells. So what all is going on in a galvanic cell? What is your anode? What is your cathode? What reaction is going on at your anode? What reaction is going on at your cathode? How are the particles moving? How are electrons moving? How are the ions from your salt bridge moving? What messes with the potential? Like this question is asking about the Le Chatelier's principle and the potential. So just take a look at this question and go, yeah, how many electrons are being transferred? What, just anything and everything that's related to galvanic cells. So if you do that with every question that's on the midterm, you're going to be in great shape for the final. All right, my last slide. Some other things that you can do as preparation for the exam. There is an ACS study guide. I have several copies in my office, which you are welcome to use when I'm there for office hours, or even if you stop by and I'm there but I'm not officially doing office hours, I'm happy to let you borrow that. I just ask that my personal copies stay on the 3rd floor of Centennial. We've got some desks over in communications. They've got some desks too, so there's lots of space for you to hang out and use that. I also have some AP chemistry flashcards, which are pretty good. Again, those need to stay on the 3rd floor of Centennial. Another thing you can do is Google Chemistry Olympiad practice exams. These are advanced high school exams written for a competition by the American Chemical Society. The big caveat on them is that they are a mix of information from both Gen Chem 1 and Gen Chem 2. And one more thing you might try, because some students have had success with this, they just Google ACS General Chemistry study guide or final exam, And the only thing that I would warn you about with just Googling something like that, sometimes you get good stuff, sometimes you get bad stuff. All right, well, come see me in office hours, and good luck with the exam.